Hello everyone. In this video, we are going to discuss about binary search algorithm. Okay, so let's get started. So binary search algorithm basically comes in a divide and conquer rule, or you can say divide and conquer algorithms. Now, what do you mean by divide and conquer? Actually, we divide our problem into parts, you can say subparts, and then we get our results. It is not necessary that we have to divide our problem only one time. It depends on what values we are choosing, and so we have to divide even up to n times. Okay, so the binary search is the condition for binary search is that it should be applicable only on sorted array. On unsorted array, this algorithm doesn't work, and the recurrence relation for binary search algorithm is t of n is equal to t of n by 2 plus 1. So, I'm now discussing about time complexity. So the time complexity of binary search is, I'm sorry, here it should be CASC case. So in best case, time complexity is order of one. That is with in first attempt we get a result. Okay, and in the worst case, the complexity is order of log n. Now you can check out the algorithm of binary search. So firstly we have to see that A is an array of elements. LES is the element to be searched in array and be the length of array. L is the starting index, M be the middle, and H or R, any name you can give, and H and R be the ending index. Okay. So let's get into the what is algorithm for it. So binary search algorithm, here I'm this statement means I am defining a function which take arguments as a, that is array of elements. Les is the element to be searched. Okay, so in this function, firstly I am assigning 0 to L and n minus 1, that is length of the list, minus 1 to R, that is the rear index or the ending index, and L is the starting index. So here the condition is if L is less than R. So this loop will work only if L is less than R. What this loop says, just a minute. Yeah. So what this loop, when we enter this loop, firstly we have to change the value of M to L plus R by 2. L is the starting index, R is the ending index. Adding both these values and divide it by 2. Now this, what is this is actually floor function. This thing is actually floor function. So what do you mean by floor function? Let's see with an example. Let's suppose you have to find floor of 4.5. So 4.5 lies between two integers, that is 4 and 5, nearest two integers, that is 4 and 5. So for floor of 4.5 is 4, and seal is the opposite of floor function. So seal function is, so if we have to find the seal of 4.5, that is 5. So in this way you have to find the value of M. So actually you don't have to find the value of M, you have to give the value of M as L plus R by 2. Okay, so if element is searched in first attempt, that is, so since M is the middle index, so we have to compare our element to be searched with the element present at the middle index. So A of M represents element present at the middle of index, at the middle index in array A. So if the element is found, then return M. So in this case, if element is searched in first attempt, in this case, uh, the time complexity is order of 1, because this is considered as the best case, because in first attempt we get our element that we have to found. So this is the case for best. So this is best case, and the rest are considered as the average, or you can say worst case. Okay, so if the element to be found is less than element present at the middle index, then you have to change the value of actually R is the ending index, to M minus 1. I will explain all these things with the help of an example. Firstly, let us complete this algorithm, and if the element that is to be found is greater than A of M, then we have to change the value of M. So here, as we are changing the value of R, this means we don't have to change the value of L and M, but we have to keep the values of both as same. Similarly here, as L is changed, so you have to keep R and M as same. Okay, so if uh, If L is not less than R, then I have to return minus 1, and this minus 1 automatically means the element is not present. Let's see it with an example. So as I've written here, pictorial representation of binary search element is present but not at the center. So it means this is not our best case. Okay, so let's suppose this is our array. This array has length 10. So it means our starting index is 0, ending index is 9. So value of R is, or you can say H is 9 and L is 0. Okay. So as we have to find the value of 23, we have to find whether 23 is present or not in the list. So firstly find the middle index. How we can find the middle index? Using this. So as L is 0, R is 9. So 0 plus 9 is 9. 9 by 2, 4.5. So floor of 4.5 is 4. Okay, 4. So so middle index is our 4. So now we have to, according to the algorithm, we have to check one of these conditions should be true. So we have LES value 23 and A of M is 16. So 23 is greater than 16. So it means we have to update our L and R remains the same. So value of M is 4. So 4 plus 1 is 5. So L becomes 5 now. R remains same, that is 9. Fine, let's see here. So as you can see here, we have to remove this list. Just I'm saying to remove, we actually don't have to remove this, because now we have to find in the list, or you can say array, whose starting index is 5 and ending is 9. Okay, so L is 5, H is 9. Again 5 is less than 9, that is L is less than R. So again go into the first if loop, and in the if loop we have to find the value of M. So 9 plus 5 14 by 2 7, and floor of 7 is 7. Okay, so value at seventh index is 56, and the element we have to search is 23. Actually, the sign here should be this. The sign is wrong. Sign should be 23 less than 56, because 23 is never greater than 56. Okay, 23 less than 56. So 23 less than 56. So as you can see here, 23 is less than 56. So now we have to update a value of R but not the value of L. So value of R should be updated. So as the value of 7, middle index is 7, so 7 minus 1 is 6. So R becomes 6. As you can see, L remains 5 and H turns to 6. Okay, now we have to find the value of middle index. So using the formula, floor of L plus R by 2. So L plus R, that is 5 plus 6 11 by 2 5.5. Still 5.5 is 5. Yeah. So here the starting index and the middle index turns out to be same, and as we have to find 23, so 23 is found at the index number 5, that is this. Okay, so depending on what we are printing, so in, so if we have to print just the index value, we can print that, or anything else. If you want, you can print that also. Okay, so here you can see the element is present at center in first search. So let's suppose you have to find the value of 16. Same is the array. Starting index is 9. And starting index is 0. Ending index is 9. And we have to find M, that is middle index. So 0 plus 9, 4.5, 0 plus 0 plus 9, 9, 9 by 2, 4.5. And floor of 4.5 is 4. So that means this is our M. uh, and A of M, that is A of 4, that is 16. Now 16 we have to found, we have to find. So our program will return 4, that 16 is present at fourth index. Okay, let's move to another example. Yeah, here this example says element is not present in the array. Let's suppose you have to search 22. Fine. So the starting index 0, ending index 9, and middle index comes out to be 4. Now you can see 22 is greater than 16, as 22 is greater than 16. So we have to forget the array before, well, Okay, sorry, just a minute, just a second. Actually, 22 is greater than 16. So as you can see from our algorithm, as you can see from our algorithm, 22 is greater than 16, so we have to update L. Now value of M was 4, so 4 plus 1 5. So value of L now comes out to be 5. A value of R remains same, that is 9. Okay, again L is less than R, so again we come in now as value of L comes out to be 5, so we have to forget our array from 0 to 4th index. Now we have to discuss, or we have to find our element in the array starting from index 5 and ending at index 9. Fine. Now yeah, since we are finding our element 22 in this array, so starting in this index 5 ending is 9, so in this we have we have to update our m, that is middle index. So 5 plus 9, that is 14, by 2 7, and 4 of 7 is 7. So a of m, that is a of 7, is 56. Now 22 is less than 56, so 22 is less than 56. So as we can see in our algorithm, 22 is less than 56, so we have to update R but not the L. So now L was, or you can say L is 5. R comes out to be 7 minus 1, that is 6. So L is 5, R is 6, and M also comes out to be 5. Yeah, so as you can see here, L is 5, M is also 5, H is 6. Now A of M, that is A of 5, because M is the middle index and middle of index value is 5, so A of 5 is 23. Now 22 is less than 23. So it means we have to change the value of 22 is less than 23. We have to change the value of R. So M, value of M was 5. 5 minus 1 comes out to be 4. Value of R is 4. Now again you have to check in this if condition. Now L value is 5. R is 4. So is 5 less than 4? No. So it means if loop uh, we have not to we have we don't have to go in the if loop, and we have to see else loop, and with else loop we are what we are returning, that is minus 1. So that means the value 22 is not present in the array we have chosen. So as I have written here, 22 and 23 not found 22 and return minus 1. Why? Because R is mid minus 1, so R comes out to be 4, and L greater than R comes, so if loop fails. Fine. So that is how the binary search work. Now we can see example for this. I have written the program. Okay, so I am just zooming it a little. Yeah, so I have done the same as was mentioned in the PPT. So the same uh, algorithm is followed. The end is called clock is just to find the time our program takes to run. Okay, so just a minute. It is asking for the length of array. Let's suppose I'm giving the length of array is 5. Okay, so enter elements to array 2, 3, 67, 90, and 507. Let's suppose, so as it is here, program is can enter element to search. Let's suppose I have to search 9. You can say 507. So it is saying that 507 is present in index 4. So you can see index 0, 1, 2, 3, and 4. So element is present at index 4. Let's try with again same 5, 2, 5, 67, 89, 1098. Any random numbers are here. Okay, array elements are as follows. Enter element to search. Let's suppose I'm giving 67. So present index 2. So here only one search is used. One pass is required to get our answer. Now again 5 and 3 9 okay, just 54 78 908. Fine. Now element to be searched. Now I'm giving that element which is not present in the array. So let's suppose I'm giving 45. So what it is printing 45 is not present in array. It is array. AR is actually name of my array. So I hope you have got what I want to say, what I want to tell you about binary search from this video. Thank you very much.